Hey everyone, welcome to today's ACE meeting on Docker and containers. Before we get started, if you'd like to follow along, I'm going to show you how to do so on your computers. You can go to, I don't remember the address, just Google Docker. And you're going to want to download this Docker desktop right here. And that'll say Windows for you. I'm on my Linux laptop at the moment because I need some stuff for a later part of this demonstration. But once you download this and start it up, at that point, once I get to the demo portion, you'll be able to just do all the same commands and stuff that I'm doing from Windows, Mac, whatever.
Do we need Linux?
No. All right. So, what is Docker? Before we start, quick disclaimer. I don't know that I'm going to teach you to hack anything today, but please don't hack things. Also, next week, we will be teaching you to hack stuff based on this stuff, which is pretty cool. So go ahead and don't hack things then either. So, Docker is a containerization app. What'd you say?
So can we hack stuff the week after that?
No. So Docker is a containerization app, which, to understand what that means, you have to have an understanding of what a virtual machine is, I think. So on our right here, we have kind of a map of what a virtual machine server might look like. So if this infrastructure block is your actual computer, on your computer, you're running a piece of software called a hypervisor. And a hypervisor is basically an operating system that lets you run other operating systems. And it doesn't have to be an operating system. It can be just a piece of software you run on top of your operating system. If you've ever used VirtualBox, that is a hypervisor. And so you basically run these virtual machines, which each have their own operating system that you run separate applications on. And the benefit of this is there are several benefits to doing things this way. A, you get to have a completely separate, independent environment for each different application you're running, where you can run whatever operating system you want with whatever applications and libraries you want installed on it. So applications aren't fighting for the same resources, or they're not able to touch things that they're not supposed to be touching with other applications. So generally, for a while, virtual machines were getting pretty big in like cloud computing and just server internet type hosting in general, because they let you use one piece of physical hardware to act as multiple different servers doing different things without really knowing about each other, which is a plus for security, portability, scalability, all of the fun itties in computing. But it's a little clunky, because each time one of these applications goes offline, or if you want to change something out, or if you get a few extra web requests and you say, hey, I may need an extra server to support everything, you've got to reboot an entire operating system, which isn't ideal because it takes a little bit. If you've ever, booted into an operating system, it takes a little bit. And there's just a lot of overhead generally. So containers came along, and what they do things a little bit differently, because instead of a operating system hypervisor, which lets you run several different operating systems, you just have the one singular operating system, and you use a container program like Docker to separate out that operating system into several different containers, which have a lot of the same isolation benefits as operating systems, but don't take nearly as long to start up or do anything with, and they're a lot more lightweight. You can store them in a lot less space. It's just generally a happy medium between running all your stuff on one machine and running it all separately. So the turbo nerd version of how this works is basically, if you remember to our Linux introduction at the very beginning of the year, you're in Linux, not in any like Unix-like operating system specifically, which is basically every operating system that exists ever except for Windows, your entire computer's state is somewhere on the file system. And the file system is a singular tree where you've got a root that has several different subdirectories. So you've got your etc directory where configuration files are stored. You've got your dev directory, which is where you can interact with devices, things like that. So the astute computer scientists among you might know that if this is a tree and it has branches, I can just take one of those branches and call it the root of a new tree. And so there has been for a long time a tool called chroot. I say chroot. Your mileage may vary. And that basically says, I want to change the root of my system. And what that does is it lets you say, hey, when I run this new binary, I don't want it to be run from this current root directory. I want you to take this directory right here and treat it as if it's the root directory. And so every time you look for something in the file system, instead of starting from here, you're going to start from here. And so now our entire system is actually down here. And you've got a whole different set of configuration files. You've got a whole different set of device drivers if you want. You've got a whole different set of binaries, libraries, things like that. And that is basically, and because of the way that things like Linux works, this even means that you could use different like distributions of Linux at the same time, quote unquote, by just having one distribution have its root folder in one place and have another distribution have its root folder in another place. And if they have different kernels, you'd be using them on the same kernel, which is a little weird, but whatever. And so what this means is you can have basically an entirely separate system with just the stuff you need to run whatever you want to run. So containers, i.e. Docker, takes this to its logical extreme with things like C groups, which is a thing that I have heard but don't really know about. It basically virtualizes your network, so it treats this little system right here as if it has its own network interface that connects to your main network interface, and a bunch of other things to basically make it seem as if in every possible way it is its own device, even though it's running on the same operating system kernel as you are running. And that basically, for all intents and purposes, means it's a totally separate system just operating on the same kernel. So kernel, by the way, because I heard the question, the kernel is basically like the lowest level of your operating system. It's the software that interacts directly with your hardware, basically. It's what makes the computer actually compute. Everything on top of that we call userland programs, which are programs that you as the user are able to interact directly with. So basically this lets you treat your userland as a completely separate system. So containers have, as I mentioned, several benefits that are specifically beneficial to cloud computing, but they also, as developers, you'll probably see them a lot for like development environments because of that first bullet point. They are very portable. Basically, you can ship your application that you are developing along with its entire system that you need to run it on, and basically eliminate the issue of, well, it works on my computer. And so whenever you're developing and you're trying to share it with a team, you'll see a lot of Docker containers being used. Whenever you deploy it to something like a cloud server or your own internal server, if it's like a web something or other, you'll usually do so in a container. And these other two benefits mainly affect that deployment. Basically, it's scalable. So like I said, it takes real quick to spin up a container versus a virtual machine with its own operating system. And it's isolated from all of the other containers running on the system. Now, there's a big asterisk on here because next week, Jonah is going to come and he's going to show us how to break that isolation if you're in the right situation. But generally, it's a lot harder to get at any other process running in a container environment versus one that's running just along with all the other things running on your server. So that was a lot of word salad, I know. So I've come up with a little example to show you kind of the benefits of containerization. So imagine for a moment it is the year 2000. The .com stock prices are to the moon, and I want to get a good ride on that, so I start my own website. And in that time period, I probably would have used what's called the LAMP stack. Basically, that just refers to I'm using Linux, Apache, PHP, and MySQL. Basically, I run everything on Linux, and whenever someone connects to my website, they are answered by the Apache server, which grabs any files. It uses PHP to load any dynamic content on those files, and PHP talks to MySQL to use any persistent state or data that may be stored. Like if I wanted to log in, that's stored in the MySQL database. So this is a very popular way of running a web server, especially back then. So you can see all of this is running on one server under one operating system. And so that makes sense. It has a few downsides. Like if I want to change out the PHP code, or if I want to update PHP, I have to take this whole thing down, run any updates, bring it back up, which again involves booting up the entire operating system and so on. If I want to run multiple of these servers, well, I've got to make sure that my database is the same database across all of those servers. So I've got to have multiple servers with their own database communicating with one another. That causes problems. And generally, if any one of these things breaks, the whole thing goes down, which is not great. So it's now, let's say, 2007, and I decide to go upgrade my system to use virtual machines. So instead of running my operating system on the server, I instead run a hypervisor. This is VMware on the server. And I split this system into two virtual machines, which one is running Ubuntu Linux and has my Apache and my PHP interpreter on it, and one is running Fedora Linux, which runs my MySQL server. I don't know if it's beneficial to run MySQL on Fedora or any other Linux distro. I just picked that to demonstrate you can now use two different operating systems if you really needed to. And so the benefits of this are now I've got a little more separation of concerns. If my PHP Apache thing breaks, I just have to bring it back up and I don't have to worry about my database blowing up. If my database blows up, I don't have to worry about any of my Apache files blowing up. If I want to scale this by, let's say, adding another web server that talks to this same database, I can totally do that. There are generally just it's a lot easier to work with this. But I still have the issue of anytime I want to do anything with any one of these, I've got to boot up an entire operating system to do so. And if I want to be scaling this up and down quickly as demand changes, i.e. multiple people are connecting to my website and it's too much for one Apache server, but the MySQL server is doing just fine, now what I can do is spin up an extra Apache server, have it point to the same MySQL server. But that takes a lot of storage and it takes a lot of time to boot up. So I'm looking at, 30 seconds to a minute really of actual extra time to boot that up. But when you've got hundreds of thousands of people going at this server, it makes a difference. So Now the year is probably like 2013 or 14. I don't know when these things come out. And I switch to a container environment. So now, instead of running a hypervisor, I'm back to running just bare Linux on my server. And on Linux, I'm running Docker. And so now I have my Docker container running Ubuntu over here, and my Apache and PHP server are going fine right there, and I've got my Docker container running Fedora Linux over here, and that's running just fine. And now if I wanted to scale this up or scale this out or do any of those cloud compute-y things, it takes a lot less time because I'm not booting up an entire operating system. I'm basically just taking a snapshot and loading that snapshot, and we're good. And this basically leads to now these things are so separate from one another that it doesn't even matter really what server I'm running this on or what the underlying hardware is. So I can realistically just start thinking about this as two separate Docker containers talking to one another. I don't care where they are, what server they're running on, what the underlying hardware is, just as long as I know that I've got two Docker containers running there. And that's the whole idea of cloud computing, is that you abstract away the actual, like, what computer is this running on enough that you can just give your program to someone like Amazon or Google to run, and they'll just throw it on one of their machines, and you don't care which of their machines they throw it on, and you're good. So that's why containers are really big on the cloud, is because they're pretty much agnostic to what the actual underlying hardware is, so long as it meets a few criteria. And with this, I can also scale this up very easily. So this is what I was talking about earlier with scaling this up. Basically, if I have so many requests that one of these Apache servers is starting to get overwhelmed, I can split it off into two Apache servers and point some of my requests towards the second one, and they can communicate with the SQL server just fine. So, again, that was a lot of me talking, so let's actually do things. So if you're following along at home, you should be running Docker Desktop now. All of the stuff we're going to do in the command line, though. The desktop application just gives you a nice little way of viewing it all. But once you're running Docker Desktop, you should be able to run the Docker command. And we're going to start with Docker psst, because that is, hey, what containers am I running? And as you can see, I'm not running any containers. Big surprise. So how do we build a container? That's a good start. So let's say I'm here and I'm developing my PHP application that's going to change the world, and I want to containerize it. And I've got all my PHP code here in this folder, and I make this Docker file. And it's a really simple Docker file. Basically, a Docker file is instructions on what to do with all of this in order to actually turn it into its own system. And so, someone's already done most of the work for us. I'm starting off with the base image PHP 7.2 Apache, which is basically someone has gone and made a PHP Docker container that has everything you need to run PHP and do it with version 7.2 on Apache. And so I copy all of my source files into the proper place, and I make sure that port 80, which is how we're going to communicate with the web server over HTTP, is open. And now I can docker build, and I'm going to tact, which is tag, that basically names it, and I'm going to tell it to build this current directory based on the Docker file that's in this current directory. And it did that really quickly because I've already done it, and it's smart enough to say, hey, nothing has changed, so I'm just going to use what you had before. So now in the ACE PHP demo Docker image, so what that did is it made an ACE ace.php demo docker image, which is basically, like I said, that snapshot of your system that you should be able to just docker run. And I'm going to, there's a few flags I need to put on here. So docker run to start up our image. I'm going to tac rm to say once you finish with this image, just remove it and don't leave it there. And I also need to map some ports. So again, we exposed port 80 in our web server, but my laptop doesn't let me actually expose port 80 on the laptop itself, so I'm going to expose port 8080, and I'm going to tell it to use that ace.php demo image. And basically, it's going to take that snapshot, start up a process that basically just, hey, here's your file system, go. And this is PHP running, or no, this is Apache running PHP. So now I can connect to my local server that's on the web and use my code that I'm logging into, and here it is. So that's pretty cool, but that was a lot of work, and I don't want to containerize my own thing. Maybe I just want to take something someone else has made and run it in that same environment, because I don't want to deal with installing everything and having all of their dependencies on my system. So I don't actually have anything in this folder because, yes, I've ahead of time Docker pulled this thing. So basically, Docker has a registry or a repository where people can upload images that they have made. So someone else did Docker build juice shop, and they built that image and they uploaded it to Docker Hub is what it's called. And so now I can pull that image from Docker Hub, and I've already pulled it, so it went very quickly, but it took a hot minute the first time I did it. But now I can take that image, and just like I did with the first image, I can docker run. And this one says to use 3000. That service. All right, and it started up. And so now I can and this is someone else's website. This is a juice shop. If you are someone who's interested in cybersecurity, this is actually a really fun little website that you can basically hack into in numerous different ways, because I think it's the world's most advanced insecure website is what they call it on their actual website. Because you basically, I think, let's see if I am up on my SQL injection.
I know we did SQL injection on this website earlier.
Yeah, I think it's, yeah. Yeah, so I did some funny characters there, and I solved a challenge that was provoke an error that is neither gracefully nor consistently handled, which is basically very bad, because if it's not consistently handled, then I could, if I was actually smarter than I am and remembered how to do SQL injection, I could totally just write a thing in here that would say, hey, instead of logging in this user, log in whatever admin you can find. So that's not good. What?
I was just going to try something for SQL injection.
Oh yeah,
I was going to say, after the parentheses, try or 1 equals 1.
Oh, that's right, yeah. That's not it. Maybe no parentheses.
There it is.
There we go.
Yep.
So now I'm an admin, or not an admin. I'm just, I am the admin because it went through. We had a whole talk on this a while ago, so I'm not going to go too in depth into what just happened, but SQL injection, cool. And I'm doing this on a Docker container. So if I want to just shut down that Docker container, there it is, and now my website is no more. But I promised you guys Minecraft. So someone has yet again done all the work for us and made a Docker image that hosts a Minecraft server. And this gets me, and if I wanted to start it up, I could Docker pull the dude's name /Minecraft and run it with a bunch of flags and options that it says to do on the website. But I'm honestly too lazy to do even that. So I've made this Docker compose file that just lists all of the options needed to actually run this server for me. So I just have to basically, over here. Oh, well.
Wow. That person.
And it starts up that server. And it should have already built everything. Yeah, there it goes.
Did you just make the world?
There it is.
There it is.
Yeah. So now, please don't clown me for the email that I made when I was 7. I should have had this prepared. You can probably hear my laptop about to take off. Here we go. Yeah, this is my CPU usage right here. Yeah. All right, here we go. Can I just do localhost? Yeah. Yep. So this isn't all that impressive because what all you do when you play single player Minecraft is you host your own Minecraft server, but they've done it for you. This time, I'm hosting this here, so does anyone happen to have Minecraft like installed and ready to go? Because I'm not 100% sure if other people are able to connect right now. Because that's my IP address. Yeah, it's my tech IP address. So if anyone wants to hop on and see if they're able to connect, I honestly don't know if this is going to work.
So we just search up your IP address?
Huh?
We just search up your IP
Yeah.
address? So what is the tech IP address and actual IP address?
As in, like, this is my IP address on the tech network,
Okay.
since I'm currently connected to tech's network.
So it can change, like your IP address changes based on what internet you're on?
Yes.
So like what if you get IP there, that is complete policy?
Yes.
Yes.
Really?
Yep.
We could just change Wi-Fi.
I thought it's
Someone joined. I'm actually, like, super... think this was Spawn. Oh yeah, there he is. No, I'm only in creative. Oh, and I did promise you guys a juice shop in Minecraft, so here we go. You guys are about to see my advanced building skills. Ooh, we got some stripped oak. I haven't played this in so long. I don't remember stripped oak even being a thing. And my touchpad doesn't work. There's auto jump? Since when is there auto jump? I hate that. It's been a hot minute since I played Minecraft. Alright, and okay, food and drinks, so surely. Alright, we've got some bee juice.
Did you just call honey bee juice?
I did call honey bee juice. So look here. Where are you, Blazer? I'm gonna give you some juice. Alright, so here's our juice shop. And that's a juice shop in Minecraft. I'm a man of my word. But that is a juice shop in Minecraft running on a container, theoretically in the cloud if we consider my laptop to be a cloud, which realistically all a cloud is someone else's computer, so we'll go with it. So, ta-da! That's the talk, y'all. What's up? So that's what we were talking about before. So this is, you're able to connect, he's able to connect to me right now because we are on the same network. Basically, tech has a firewall which doesn't allow external people to connect to something that's on the tech network unless Danny Shales has ruled it to be okay. So the same thing happens at your house with your little home router that acts as a firewall. And basically, the router is probably set up to not allow anyone to connect to your home network unless you deem it to be okay. So in order to let someone connect to your Minecraft server at home, you have to go into your router settings and say, hey, it's okay if someone connects to this network on this specific port on this specific device. And that's what port forwarding is. It's a little different because on a home network, so tech's network is set up so that basically like my IP address on the tech network is an actual like internet facing IP address. You're just not able to connect to it from the internet. On your home network, there's your IP address is a private IP address, so it's 192.168.something.something. That basically means this IP address only actually exists within this network. So what port forwarding does is you take your router's IP address, because your router is the only thing that has an actual internet-facing IP address. You say, hey, whenever someone connects to my router's IP address, point them to this internal IP address at this internal port. And that's what port forwarding is. So I'm sure we could at some point, but
That's covered all in like CSC 400.
yeah, if you take like CSC 400 or 450, which is the networks class, you go over that on like day 3. So, any more questions? Yeah. No, I don't have to be connected. So that's that's what I was saying earlier about like single player worlds. Basically, you're thinking of like a single player Minecraft world where basically you log into your Minecraft launcher and say I want to play single player, and it spins up a local server for you and you play on it. What we've done here is actually we've made a server that I don't have to be connected to at all, because he's still connected to it, as you can probably see, I hope. Yeah. Did Did he actually?
No.
Okay.
Gaslighting me.
Yeah. And so I can even go into like, what is it? Docker exec. So what I've done here is there's a thing called Archon, which is how you control Minecraft servers. And oh, it's the music. Okay. And I can like say things to him. And it'll show up in his chat. And that's him responding. So, and I think if I don't know any command. This is the only command I know, so bye. Oh yeah.
I'm sorry, I chose violence.
And he's dead. Oh, someone else joined.
Time set.
Oh yeah.
Something passive, not
Yeah, so like, and this is all happening, like, I'm no longer in the game. Like, I can even shut it up by quitting out entirely, and the game's still going because we're running the server independent of running the game, and that's all because of Docker.
So how does someone join if, like, you don't do that local? Like, do you just, so if you finish port forwarding by basically saying, hey, when they try to connect to your internet, send them this IP address and this port, do they just,
You would have to give them whatever IP they need to connect to.
so like the router's IP?
Yeah,
So you find your router's IP and then you give that to them and that's how they connect to it?
yeah.
But then, so you just run this and then you can give them your IP after you port forward.
Yeah.
Yeah, understood. But then, what IP are they, is the port, like, which container? Is that basically directing them to the container?
More or less, yeah.
And then, so the IP is just saying, okay, this device, and the port is like, okay, this container on this device.
Yeah.
Okay.
You can do this with anything, right?
Yeah.
Yeah.
So I just use Minecraft as an example, but
So-
like actually something I did recently was I have a password manager. And basically what that is and how you do that is you have to have some kind of like server that you store all your passwords on, and whenever you want to connect to that server or whenever you want to get one of your passwords to log into something, you connect to that server, give it your like master password and say, hey, can I get this password? And to do so, you have to actually host the server. And so I have my Raspberry Pi that I got freshman year at home with Docker running and that server running in a Docker container. And I've got port forwarding and all that fun stuff going. So yeah, you can do this with any kind of internet-facing application. I'm trying to think of other ones that people do. Seth, help me out here.
I mean, you have Juice Shop.
Yeah, Juice Shop is another one.
Web application to, yeah, really.
Yeah. And then like the actual like professional application of this is, let's say I'm a like software company that contracts with AWS, which is Amazon's their cloud service, and I say, hey, I want to deploy this bit of code that I wrote to run on your web service so that anyone who wants to use my stuff can connect to you and do all that. What you would do is you would build a Docker image out of it, or a container image of some kind, and you would ship that over to Amazon, and Amazon would pull that image down and run it as a container. So you can put whatever you want, you can put whatever kind of computer program you want into a container. Is the short way of answering your question that I kind of meandered around. Yeah, what's up?
On like a local network, you need to port forward for something like a Minecraft server to work on the internet. But is there a way to do that on text network to like have to host a Minecraft?
Not unless you're Danny Shales.
Yeah.
He is the guy who like runs all of tech's network stuff.
He has so much power over everybody.
I'm actually lives in the basement of Barney Tower.
That's mean.
Well, that's where all the technical support is.
He's
I
not
actually-
So if he's head of all of it, then
Yeah.
He's not real. He's a boogeyman.
He doesn't-
The
he
other
doesn't
technical
control-
people
he
like
doesn't-
point
he
to
doesn't-
the
he doesn't
little
stand up.
basement.
Yeah.
Like,
Who
how do I
runs
get
the
this,
whole
the,
There's a tunnel system.
do I just search up, like, container for Docker for Minecraft server or something, or?
Yeah. So, I looked up Minecraft Docker, and the first thing that popped up was this, and this is Docker Hub, which, as I mentioned, where you're pulling all the actual containers from. And basically, you just need to take this command right here and run it, and that's the simple way of running a Minecraft server. But if you actually want to, there's a couple things that, so this will, because it's a completely self-contained container, it will, anytime you shut it down, lose the entire world because the world existed within that container. So you have to use what's called a volume to connect a certain part of that file system where it stores all the world stuff on a actual folder that exists on your computer. And that's what was going on. Like, this is where I copy pasted that file from, and you could do this as a command, but instead I just did it here. You have a,
You
yeah,
made like a text file that you opened up or something like that?
yeah. So
Can you control V stuff into command lines?
yeah,
Because I've noticed that when I try to do that, it just,
sometimes you have to use Control Shift V.
yeah.
Command prompt is weird.
Yeah, command prompt is also weird on Windows. All right, bye.
Blazer left. You should have kicked him.
Ben, I'm right here right now.
All right.
Nobody leaves.
And I can go ahead and shut down.
So what happens if you never stop it? Is it just always up?
Yeah.
So like I could like run it from like my desktop at home and just connect to it whenever I want to?
Yep.
There's a really funny picture online of like a laptop. It's like kind of closed, not totally. It's got like a note on top that says, "Don't close this." Like server like on here.
There have been like actual like horror stories that you can read about on the internet of like, I think it was like Twitter, like long ago, so like before now. Like someone at Twitter found like a closet with some like laptop, or I think some like, maybe it was a laptop or like an old computer that just didn't look like it was doing anything, and like he didn't even think it was plugged in at the time. I guess he was wrong, but so he shuts it down and unplugs it and everything, and finds out later that it was actually like some critical piece of business infrastructure that took down Twitter for a couple hours. So, yeah. You had your hand up? So.
And there's also Facebook that accidentally removed themselves from like.
Oh, yeah. Facebook accidentally removed themselves from the internet by, I don't think that was by like taking a server down or anything. I think they just like pushed a change to DNS that,
I'm gonna say
yeah.
I